This is the video recording for online probability and stochastic process homework 2, problem 5 by page 10. And so for the fifth problem, the problem setting is that we are given the custom flow as a grocery store, which can be viewed as a Poisson process, which is exactly the to note the probability of the number of customers arrives in the interval of time 0 to time t equals to k. This is equal to e to the degree of minus lambda times t times lambda t to the degree of k divided by k exclamation mark. And so we are also given one condition, which is the probability that two customers in 2 minutes, at least one customer arrives equals to 0.3, which can be written as the probability equals to where t equals to 2 and k equals to 1 in this equation, and equal to e to the degree of minus 2 lambda times 2 lambda to the degree of 1 divided by 1 exclamation mark. And this value should be equal to 0.3. And given this condition, the first questions ask us to find the value of lambda. If we do it in this way, in the first view of point, and we just need to rewrite this problem, probability equation as e to the degree of minus 2 lambda equals to 0.3 divided by 2 lambda. And as much as I tried very hard to find the solution of this equation, which can be also illustrated here by these two different functions on both sides, the cross point should be the value where we can should be the point where we can find the value of lambda. But unfortunately, this is very hard to calculate or resolve, so we have to look at it in a different way. And so if we see the next page, and if we just look at it in the other way, just trying to find the probability of the opposite event of this conditional event, which is the probability of finding no customers arrives in 2 minutes, it can be very easily found to be having this equation where 1 minus this probability where no customers arrive in 2 minutes should be equal to 0.3. So rewrite this equation as 1 minus e to the degree of 2 lambda times 2 lambda to the degree of 0 divided by 0 exclamation mark equals to 0.3. We can easily get e to the degree of minus 2 lambda equals to 0.7. So lambda should be equal to minus ln 0.7 divided by 2, which is approximately 0.178. So having the result of value of lambda for the first problem, we can easily find the probabilities in the following 3 questions. The second question asks us to find the probability that in 3 minutes no customers come. And this can be straightforwardly rewritten as e to the degree of minus 3 lambda times 3 lambda to the degree of 0 divided by 0 exclamation mark. This is exactly the value of e to the degree of minus 3 lambda, where lambda approximately equals to 0.178, and this is approximately equal to 0.586. Excuse me. For the third problem, we are to find the probability of at least 2 customers arrived in 10 minutes, and this should be also similarly rewritten as 1 minus the probability of at most 1 customer arrived in 10 minutes. So it can be divided into 2 parts, where the first part is actually there are no customers come in, and the second is only 1 customer come in 10 minutes. So this can be written as 1 minus the sum of e to the degree of minus lambda t times lambda t to the degree of 0 divided by 0 exclamation mark plus e to the degree of minus lambda t times lambda t to the degree of 1 divided by 1 exclamation mark. Then this can be rewritten as 1 minus e to the degree of minus lambda t times 1 plus lambda t, where in this equation lambda is approximately 0.178 and t equals to the constant value of 10. and this should be approximately the value of 0.531, thus having the result for the third question. For the fourth question, we are to find the probability of in 1 minute exactly one customer arrives. So it is pretty straightforward. We can just rewrite it as e to the degree of minus lambda times lambda to the degree of 1 divided by 1 exclamation mark, which is exactly lambda times z to the degree of minus lambda, approximately equals to 0.1.9. So we have obtained all the results for this question. Thank you.